everyone. My name is Lenin. I've been working with Cisco for about 10 years now. I'm based out of Dubai, and for the past couple of years, I've been heavily working on service discovery, migration, reconciliation. And today I'm going to be presenting on a framework that I have developed, and it has been used in different accounts, and we have had major success stories. And to start with, I'm going to give an example not related to the network to understand the concept that I'm going to be explaining, and then we'll take an example of reconciling L3 VPN services. So without further ado, I will just walk you through the agenda. I'm going to cover what is service discovery, applications of service discovery, and what is this MVR framework, the architecture and features, and the different stages of service discovery in NSO using MVR. So what is service discovery, right? Service discovery is basically identifying the service instances in the network, either by means of operational data or by reading the configuration, right? But in NSO world, what we do is we normally read the configuration. But if you have any assurance systems like NMS systems, you can still find out some service instances from the operational data through, let's say, SNMP walks, right? So what basically completes a service definition? We basically identify a fixed set of DevOps parameters. Let's say, for example, you have 10 parameters which is required for your service and which is deploying a specific set of configurations, right? So when will service discovery be complete is basically when you have all those 10 different services, and then you can import that in NSO database, right? So we have to identify these parameters, which is basically residing in different sections of the configuration. We correlate them, and then this is how we complete the service discovery, right? So service discovery doesn't necessarily mean reconciliation all the time, right? So where is service discovery used? The applications. So we use service discovery in migration. So for example, you want to migrate L3 VPN service from an iOS device to an XR device. It's a very, very common use case. And this is actually when MVR was developed, right? Another application could be reconciliation. So we have a lot of services in brownfield network, and we want to discover them and import them in NSO for service lifecycle management, CRUD operations. Or another use case could be a simple inventory of service, because we don't necessarily have to, let's say, discover the entire service, but some customers may need only a subset of the service inventory. For example, maybe let's say a service ID which is identified from their building system, and you just want to have, okay, what is the device, what is the VLAN, right, for example. So this is an example of how the network migration looks like. If you see here, so we have a source iOS device, and then you do the migration, and we basically translate the CLI, right? So in essence, we are keeping all these parameters exactly the same. It's just that the CLI changes, and then some additional configuration we might have to do it, right? Another use case is this reconciliation. If you see here, okay, so here if you see this NSO package, normally when we do reconciliation, this tend to be an action package which reads the configuration from the network, which are highlighted in yellow, because we are only interested in these parameters. So these are all the parameters we are discovering, and which is being fed into this, service package. So the entire thing is orchestrated by an action package, normally. Right, this is an example of reconciliation. So what are the high-level steps involved in service discovery, right? So the first thing we do is parameter extraction. For example, you have, if you talk about L3 VPN service, we normally have a VRF definition. We have the layer 2 interfaces where the VRF are attached. And finally, we have the PECE routing protocol. So we extract all those parameters, and what do we do next? Because we may have, let's say, tens of VRF, hundreds of interfaces, but how do we tie them together? That basically is done during the correlation phase, right? And what do we do at the end of the correlation? We have a service payload, meaning we have grouped these parameters into buckets of let's say, a specific service instances, right? And eventually, what do we do with that data? We either store it in the service inventory, or we reconcile them. Or we can even use it for migration, because the service inventory, or the model that we are storing, it might have a service point, which might actually trigger a service callback, which might lead to a migration, right? So let's see, what do they actually mean, all those three steps. We'll take this example where we have, let's say, in a company, we have two types of employee. Let's say, for example, full-time employee and part-time employee. And in the first box, sorry. Oops. All right, so the first box basically corresponds to the employee personal data, right? And which are uniquely identified by employee IDs. And there might be other database table where you have the bonus data for the full-time employees, where you might have, let's say, the salary data, right? And for part-time, you might have this information. Let's say, for example, their hourly rate and how many hours they've worked. So let's say the requirement is for us to look into this data, and then we write a package to look into these different data sets, and then we have a service called pay employee wage, right? So what do is we basically compute let's say, the salary and the bonus, or we compute the wage for the part-time employees by computing, by looking at this data, right? So at the end of the correlations, let's assume that these four data sets are extracted somehow, right? Let's say from CDB. And then in the end, we want to have something like this. So this basically is correlation. Right now, I've given this example, but when we actually look into the network, what this could correspond is this first box might be a VRF definition, right? This might be a list of interfaces using all those VRF, and somehow we need to correlate all of them and then come up with our service payload, which is equivalent to this. So what is MVR? So initially, when we first came out with this framework, it had a lot of features, like we do pre and post checks. We even do service reporting. As in before the migration, we capture all the KPIs, the service metric, and after the migration, let's say we also capture the metrics on the new platform, and then we compare those metrics, right? So it had a lot of features, and that's why the name migration, validation, and reconciliation. Right now, it's so with the recent version, I have ported it to a more object-oriented framework architecture, and I'm still yet to port all those features. So it's a service discovery framework written in Python 3. As I mentioned, it's object-based architecture. And what this is, it's basically an action package with a bunch of Python functions and methods. So what does it do? It basically abstracts all this repetitive code that you might write. So for example, before you do any service discovery, you might want to do a devices sync from. So all those repetitive code are basically abstracted. The developer basically focuses only on the service discovery logic, right? And another thing is, this is technology and vendor agnostic tool. Why? Because the service discovery framework, this MVR framework, heavily relies on the data that is present in the CDB. And the core functionality resides in how the data is getting extracted and how you correlate them, right? Okay, features and benefits. So it's easy to use, plug and play. And like I said, it's solely the discovery focused. You don't have to worry about all those handling different error exceptions. easily extendable, reusable. And another thing is this decoupling of the service discovery code and the service creation code. So we have seen different frameworks, service discovery framework, where the discovery code and the service inventory code or the template application code is very, very tightly coupled, right? One of the cool thing is with this framework, the discovery code is different, is separate, decoupled with the service discovery, with the service creation code. Meaning, when I give you that example of how do I, let's identify the employee wages, I didn't care about what you're going to do with the data, right? You can do whatever you want with the data. You can write it into any model, right? So that is basically how it is decoupled. Okay, and lastly, I'm including a package generator script, which is, you say MVR make package, and it will generate all the required structure and folders and with some pre-generated config. Okay, what skills do you need to start using this service discovery framework? So first of all, you need to understand what service you are discovering. And how do you know this? So normally in, let's say, in any reconciliation or any migrations project, what we do is we have a dedicated network expert, and we always collaborate with them, and then they gave us the logic. So once we have understood that, we basically implement it in our code. Second thing is, for sure, you have to know NSO and XPath filters. I'm sure if when we develop any Yang, we use this show running config pipe display XPath, right? And we could use it for leaf references and stuff. So you need to know this because this is where your data resides, and this is how you can extract the data using the framework. And you need to know some list comprehensions and filters. Okay, architecture. So these are the different class implementations. MVR init basically stores all the metadata like the execution ID and stuff, everything internal, right? And then we have something called as Yang. So before I come to this, so MVR is basically an action package, right? So in action package, you have this input, and then you can define your own custom inputs. And this is our starting point, right? So for example, if I wanted to do let's say an L3 VPN, let's say reconciliation, I could have a different approach. Say, for example, I want to target it on per device and then per VRF, and that VRF may have n number of interfaces. So it's up to how you want to design it. So you have the flexibility. So when you have agreed on what you're going to do, how your design is going to be, let's say you will know what your inputs to provide, right? So that basically is getting mapped in this object. Why? Because it is using the framework, it's getting inserted, it is available to all the subsequent code that we're going to see in a bit. So this is the most interesting part, DX. This is the data extraction object. This is where the cool thing happens, right? So normally when you want to access or retrieve any data from NSO CDB, you use MAPI API or Magic API, right? And you get a root object, and then you navigate, and then if the attribute doesn't exist, sometimes you get an error. So here you don't have to do any of those. You just need to know where that data is located in the XPath, from the XPath perspective. And you can always get it by executing show running config pipe display XPath, right? So think of DX as like a simple Python function which accepts some parameters, and it will extract some data and give it back to you in some standardized format. Right? Correlator, like I said in that example. So correlator basically correlate all the extracted data. This is where we write custom code depending on your service. It can be L3 VPN, it can be L2 VPN, it can be anything, right? And then finally, template engine. So what does it do? Once you have identified your service, you want to basically write it into, dump it onto NSO CDB, right? But template engine doesn't need to know what it is, because that is going to be your RFS data model, which might have an action point, service point, right? All right, so putting all of them together, it looks something like this. So we start off with the init object, and then it passes some information to the yang input object, and then this is our starting point. This is where we provide our input, and then we start executing the DXs. You can chain the DXs, meaning the output of one DX can be fed into another DX as an input, right? So on and so forth. Eventually, once this has all been extracted, correlator, you can implement n number of correlators, and each correlator have access to all this data. So example, let's say you have, you need to do a reconciliation of multi-vendor environment. You can, let's say, Juniper, Huawei, iOS, XR. So you can have different correlators for each of those platforms, which might eventually write to a single service model, right? So basically, it's you are segregating the service discovery code for each of the vendor type, but you might have different, DXs for each of those vendors. All right, so I will move on to the demo. And I will take that employee thing as an example. And then the last few minutes, I'll show you the reconciliation of an L3 VPN service. All right. All right, so before I proceed, I'm going to just give you guys the context. So here, if you see, I have these different packages. Let's say employee data. What does it store? It basically store the employee personal details, like, I'm just going to show it to you. So for example, I am storing here like employee personal data, like the employee ID, the name, employee type, address, start date. Right? These are employee personal details. Now, it also stored the wage details, like salary information. If the employee happens to be a full-time, he gets salary and bonus. Right? If it's part-time, we just need to know the hourly rate. And then this is specifically for the part-time employees, and for the month, and then the month is the key, and then for each of this employee, the part-time employees, you have the hours worked, so that we can compute the wage eventually. And then we have this pay wage service. It is responsible for paying the wage to the employees for both the part-time and the full-time employees, right? So you can think of this as a service RFS, right? So it pays per month, right? So what we need to start off with is, we need to look into, we need to start with the month as a, the month as an input. So how do we extract all these details, and how do we, let's say, connect this to, is basically done using this MVR package. So I have already generated this package. So if you see here, this is what I mean. This is an MVR package. It's just a simple action packages, same structure, nothing special. The only thing is this will be all generated for you. And this is where you put your custom inputs. This is actually where you do your custom inputs. Everything else is untouched, right? So I'm just only interested in the month. Right? So let's say I want to pay the employees for the month of January, February, March, and so on and so forth. So let's start with, the first thing is I need to find out all the employees, right? So before I proceed, so here, this is the input for my discovery. Now, if you look at this, if you recall the Yang input object on the slide, this is what I mean, right? So this is a class implementation for the Yang input object. So what does it do? It basically maps the this input to this, right? So if you see inputs, input, and month, I'm basically extracting this input and then storing it in this key. Let's say I'm calling it wage month because I need to pay the employees, right? So first step is done. And now when we come back to this, the main workflow, discovery workflow, this is what we have. So this is again a class implementation of the MVR workflow. This is the callback where your main logic resides. And this is something that we always do in the beginning. The MVR init object, like I said, the metadata like execution ID and stuff. And then you pass in the uh, metadata to the input object. So this is basically what we have done here. This is the instance, right? All right, so this is the start, and then this is normally what I do, like a hello world example to ensure that everything is working fine. So I've compiled it, and this is the backend package that I mentioned earlier. So, all right, so once I'm done with this, what I'm going to do is any code changes that I do on Python, I execute this command mvr pkg manager redeploy, let's say employee demo. So let me just execute. So this is how it's going to look like mvr execute, and then you have your discovery code, and then this is the input. I'm provided month, January, commit. So before I proceed with any commit operations, I first have to do the data extraction check, right? So this is why we use the dry run format data extraction result. So when I see this, you see the input is recognized. You have a wage month. Now what do I do with it? The next step is to get all the employee details, and then this is where we need to start writing the DX, and that already has been done. So now these are all imported automatically. So I start writing my DX. This is how it looks like. You have the three different methods, right? So data source, where is this employee details located? It is located under the short display, let's say display XPath. So here, this is located here, right? Employee data, display XPath. And these are all the fields that I need. I need the employee ID, I need the name, I need the employee type. So I go back here, then I'll just say this is my base XPath, and these are the details that I need, like the employee ID. This is the actual leaf name here on the right side. And this can be anything that you like to name, right? Because eventually you will access all these details with using this key. Now once you're done with this, you save it. And then this is how I can extract these details. All employees, and then I say employee input object, and then I pass it on to the employees DX. And this is how it's going to execute. Let me save it. PKG. Right. So this is how you get all this information. Now I've done this already, and I don't want to spend a lot of time here. So let's say I'm going to also extract the full-time salary information, part-time rate, and then the part-time, let's say, effort for the part-time employees. Now here I have all the data extracted already. Now this is just a simple Python dictionary objects. You can access all of this and then correlate to, calculate your stuff. And that is done in the correlator object. So if you see, I have a full-time wage correlator and a part-time wage correlator, right? If I go here, I'm not going to go through the code. So this is how I calculate it. And then eventually I want to, let me just do this. So how do I see the correlated code is basically I will run this command called correlated result. So here I have, you see, for both the correlators, I have this is full-time employees, right? So now I'm ready with the discovery, and now I want to pay the employee the wage to the employees. So this is why I have this template engine object. So this is where I have this is how I integrate to the RFS. So this is the config template, wage pay wage service, and you basically use all the variables that you see on the correlator, right? That's the employee ID, the wage month, and all this. You just put it here, and that's it. And let me save this. So how do you check the template application? You just use the NSO out-of-the-box format, CLI, native, or XML. In this case, I don't have any native configuration, so I'll just say CLI. And this is how it writes to that employee model, the pay service model. So just do commit, and that's it. Right. I just need another 5 minutes where I will show you the reconciliation example. So yeah, so if I do show running config now, pay wage service, so you would have all the details for both full-time and also for part-time. All right. Now, so this was just an example used to so that it's easy to understand. I'm now gonna quickly show something in the for reconciliation example. So let's say I have a service RFS which takes in this the device as an input. It has some VRF object, VRF definition, and then I have some interfaces which is using this VRF. You configure some IP address and you have this, right? This is one. Let's assume this is one service. So I already have prepared the pre-config, so which is this. So we have got so many different VRF, and then you have multiple interfaces. It's going to do a load merge. Okay, now I have this reconciliation example, L3VPN reconciliation code. So this is just a real quick check. So here, if you see in this example, I have provided the device as an input. I'm discovering all the VRF, and then I'm discovering all the interfaces using those VRFs, right? So here I have different data sets. For example, the VRF XR. The same way I have developed all those DXs that I showed earlier. I'm getting all these different parameters, and you have this all three layer interfaces, all those different fields. Eventually, I correlate all of them. Then I say, when I do commit driver out from it native, since the service is already present, you shouldn't see anything, right? Which is expected. But if I do a CLI as an output, you will see the service model, right? And it is successfully discovering all the services. Now, what I'll do is I'll just do a commit with no networking flag. So this basically should write into simple L3VPN service, right? The service seems to be half discovered. Now, if I do a no service, simple service L3VPN service, so this is not going to remove anything because it has not been reconciled yet. So what do? I have to execute the reconcile flag command. So I just do this. So you have this option to discard and non-discard options. So I'm just going to discard all the non-service related configs. So once I do this, if I do no simple service L3VPN service, commit driver, it should remove those services. So you didn't have to write any special code for reconciliation. It's just a template call. It's all handled internally in the background. That's all. I tried to squeeze in a lot of information. It wasn't like so. Feel free to reach out to me for any questions.
Yeah, any questions? We have time for at least one question. Yeah, do we have any microphones there? Yeah.
Lenin, do you also have built-in functionality for error handling and reporting if anything fails in that feature?
So there are so many different features I haven't covered yet. So for example, in any service discovery, you might want to, let's say, do some logging, right? Maybe in the discovery phase, it might look like a service, but it fell in one condition, so you're not categorizing it as a service. So you can log all of those. There's a special method for that. You code it in the correlator code, and then you will have a GUI report. You can get that.
And are you able to support multiple logic? Because most of our customers don't have standard configurations, or some configurations will be missing key elements that you were able to skip over. Or
correct. So there is this, for example, when you want to do reconciliation, you expect to push minimum or no configuration, right? So there is this flag which says skip modified services. So you can say blindly reconcile it, and if it detects any configuration being pushed, it will ignore that specific service instance.
Any more questions? Okay. Next speaker then. Thank you. Thank you, Lenin.
Thank you.